Let's continue the chapter Mechanical Properties of Fluids. Hydrostatic Paradox. Hydro means water, static at rest, and paradox means that something taking place surprisingly. Consider three vessels of very different shape. You may take of rectangular, triangular, or any other shape. And we have a source from which water enters into these three vessels. Water enters through the horizontal base, which is the base of these three vessels as shown. The three vessels A, B and C contain different amount of liquid but all up to the same height. As on filling with water, the level in the three vessels is same, though they hold different amount of water, because water at the bottom has the same pressure below each section of the vessel, and the pressure is dependent only on the height. Therefore, in all the three vessels, at the height reached by the water is same, irrespective of their difference in shapes. And this experiment is known as hydrostatic paradox. Let's solve a numerical example 10.2 of your NCERT based upon the knowledge we have studied in the last topic. You have to calculate the pressure on a swimmer 10 meters below the surface of a lake. Here height is 10 meter, density is 1000 kilogram per meter cube, and acceleration due to gravity here I am taking as 10 meter per second square. So by using the equation P is equals to PA plus rho GH, and on putting all the values, you will get the pressure as 2 atmospheric pressure, or you can say 2.01 into 10 raised to power 5 Pascal. That means this is an increase of 100% in pressure from surface level. At a depth of 1 kilometer, the increase in pressure is 100 atmospheric, and submarines are designed to withstand such enormous pressures. Atmospheric pressure. Pressure exerted by the weight of the atmosphere. You know that atmosphere is a mixture of different gases. All these gas molecules together constitute some weight, and by virtue of this weight, there is some pressure exerted by the atmosphere on all the objects. And this pressure is known as atmospheric pressure. The pressure of the atmosphere at any point is equal to weight of the column of air of unit cross-sectional area extended from that point to the top of the atmosphere. And at sea level, its value is 1.01 into 10 raised to power 5 pascals. How can we measure atmospheric pressure? It is measured with the help of a mercury barometer as shown in the diagram. It consists of mercury. There is a tube which contains mercury and is inverted inside the trough, which also contains mercury. The one end of the tube is closed and other end of the tube is placed inverted inside the trough. The inverted tube, which also contains mercury up to a certain level, and the space above the mercury in the tube is occupied by the vapors of mercury. The pressure here can be considered as 0. The atmosphere will exert some atmospheric pressure on the mercury level. As a result, the mercury level decreases in the trough and it increases in the tube. And this increase in the level will determine how much pressure was exerted by the atmosphere. The pressure exerted is directly proportional to the increase in the mercury column of the tube. And we can say that pressure at point A is same as pressure at point B. That means it is H rho G and is measured in terms of how many millimeters of mercury rose in the column. Greater the height, greater is the atmospheric pressure. And when the height in this column becomes 76 centimeter of Hg, we can say that the pressure applied is equals to 1 atmospheric pressure. Units of pressure, you know, SI unit is Pascal. And pressure is always measured by taking sea level as a reference level. Another unit of measuring pressure is torr and bar. Now, how to measure gauge pressure? It is measured with the help of an open tube manometer, as the diagram is representing an open tube manometer. It consists of a U-tube containing a suitable liquid of low density such as oil for measuring small pressure differences and a high density liquid such as mercury for measuring large pressure differences. One end of the tube is open to the atmosphere and other end is connected to the system whose pressure we want to measure. The pressure at A is equals to the pressure at B, and we know that P minus PA equals to rho GH and is proportional to the manometer height H. Pressure is same at the same level on both the sides of U-tube containing fluid. For liquids, the density varies very little over wide range in pressure and temperature, and we can treat it safely as a constant for our present purposes. Gases, on the other hand, exhibits large variations of densities with changes in pressure and temperature. And unlike gases, liquids are therefore largely treated as incompressible.